Alright, so I think I'm recording. Let's take a look at more examples, more problems of finding the roots, the x-intercepts, uh, the of polynomial functions. So we have this rational root theorem, also called the rational zero theorem, that allows us to help us factor polynomial functions basically and to find x-intercepts. It wants us to look at the factors of the constant term. That's what they call a naught. So the factors of 4, I've got plus or minus 1, plus or minus 2, plus or minus 4. My leading coefficient, that's what they call a sub m. It's a prime number 3, so we just have factors of 1 and 3. Using this to create a ratio, we'll create a list of possible zeros, possible x-intercepts, if my graph crosses the x-axis, and if it crosses at a rational number, it'll be in this list. If it crosses at an irrational number, well, this theorem doesn't help me in finding those x-intercepts. So these are my possible numerators. These are my possible denominators. So I take all of these divided by 1. 1 divided by 1, 2 divided by 1, 4 divided by 1. Then I come over and I take all of them divided by 3. 1 divided by 3, 2 divided by 3, 4 divided by 3. We might go through this entire list and not find any zeros to this function. The graph may not cross the x-axis at any of these values, which is a little bit of a lie. With a third degree and the fact that we know the end behavior of the graph, the fact that we know polynomial functions are smooth and continuous, with a leading coefficient that's positive and the degree is odd, the end behavior is going in opposite directions and up to the right. If I have to connect this dot to this end to this end to be continuous, I know that I'm going to have to cross the graph at least once. So I know there's going to be at least one x-intercept, but I don't know if that number is going to be a rational or irrational number. If it's a rational number, it'll be in this list. And maybe it comes down and crosses it 3 times, and maybe those are all rational numbers. Maybe there's 1 number, 2 numbers, or 3 numbers in this list, but then again, some of these may be irrational. We don't know. So to find them, we can do one of two things. We can plug in values into the function and see if there's an output of 0, or we can just do synthetic division and see if there's a remainder of 0. So that's what I'm going to do, is the synthetic division. Now, this is one that I noticed that although it's in standard form, it's missing x. So I'm going to rewrite f of x as 3x cubed minus 7x squared plus 0x, because there is no linear term, plus 4. I'm going to need that 0 in my synthetic division just as a placeholder. So if I start trying these various values, let's try 1. Let's peel off 3, negative 7, 0, 4. Pull down 3, negative 4, negative 4, negative 4, negative 4, 0. We got lucky and we found one right off the bat. So what does that do for us? Well, it allows us to factor this expression. So I know that this f of x can be rewritten as a product of x minus 1, because if 1 is an x-intercept, if 1 is a 0 of this function in factored form, we write it as x minus 1, and then I have 3x squared minus 4x minus 4. So now that I've got it down to a quadratic, I know I have the factoring skills to factor quadratic expressions, and if they don't factor, I have the quadratic formula or completing the square that will always work. So I know I'm going to be able to find solutions to this equation. To find the x-intercepts, you let y equal 0. And let's look and see if we can factor this. If we have 3x times x, that'll get me 3x squared. Now, with the negative 4, I know one's going to be positive, one's going to be negative, and I know possible combinations, 1 and 4 or 2 and 2, but I have to think about the signs there. I need the middle term to be negative. So, let's see here. What if we try a negative 2? That'll give me a negative 6. Positive 2. Let's try this because positive 2 times a negative 2 is negative 4. And the 3 times the negative 2 is negative 6. And negative 6 plus 2 is negative 4. So there we found it. Now, if that was too quick for you, you can do the x method. So maybe I should do that in just a second here. We have answers of 1. We have answers of negative 2/3. And we have answers of 2. It was a third degree expression. I found 3 zeros. I found all of them. Now, this 3x squared minus 4x minus 4. 3x squared minus 4x. I better check that I remembered that right. I don't trust myself. Minus 4x minus 4. So this x method that some people have learned in Algebra 1 here, or even in Algebra 2, they suggest that you put an x over the middle term. And now at the top of the x, you always take the first term times the last term. That gets you negative 12x squared. And then there's a trial and error. You're looking for two numbers when multiplied together give you this negative 12x squared, but when added together give you negative 4x. Well, negative 6x and 2x do the trick. If you multiply these together, you get negative 12x squared, and if you add these together, you get negative 4x. Well, so you say, so what? Well, they then suggest that you come down and put that information in a table, because in a table, it's a nice organized way for us to remember we're trying to factor this expression. We return to the first and last value, and we write them along one diagonal. And then we look at the values that we found in our x, and we write those along another diagonal. And it doesn't matter along the diagonal. You can switch. I could have written the 2x here and the negative 6x here had we wanted to. So horizontally, I look and say, well, what do these have in common? Well, they're both even numbers, so let's write a 2 here. Vertically, well, they're both even numbers, but hey, they also have a negative sign. What if I factor out a negative 2? Now I can check. Positive 2 times a negative 2 does give me that entry there in the table of negative 4. If I go across here, both of these are divisible by 3, and both of them have a factor of x. So what's common to both, the common factor, the greatest common factor, is 3x. And 3x times negative 2 is negative 6x. Vertically, if I look at this, we say that 3 and 2 are relatively prime. They only share a factor of 1. But however, they both have a factor of x here. So 3x times x is 3x squared. So this x method has allowed us, this 3x2 on the left-hand side, we write it as 3x plus 2. And across the top, this x and negative 2, we write it as x minus 2. And that's the same factors that we got when we just kind of, worked it out in our head and got 3x plus 2 and x minus 2, 3x plus 2 and x minus 2. So I hope that helps.